Hey geometry folks. For your first day assignment, you were meant to review a lot of the concepts that we've been covering from units 1 through 4. Unit 1 being the foundations of geometry, Unit 2 being our logical reasoning section, Unit 3 being about parallel lines, and Unit 4 being about triangles and their angles and their sides. So this is meant to encompass all those concepts that we've been talking about. So why don't we go through and actually work through this entire review packet, and you can actually see my reasoning behind these and also refresh on any concepts that may have been a little tricky when we were first covering them. Let's go through the first question. Right? It says find the midpoint of the segment whose endpoints are 3, 2 and -7, 4. Right? So when we're working with these kinds of problems, we want to make sure that we're picking up on any key vocab so that we know exactly what the question's asking us for. So what I'm seeing here is that I need to find the midpoint, right? So when I see the word midpoint, I want to think about my midpoint formula. And this is going to be finding the average of my x coordinates. So x1 plus x2 divided by 2. My y coordinate is going to be y1 plus y2 divided by 2. Right? So let's move on to what my endpoints are then, right? So I'm actually given my endpoints, and my endpoints are, let me highlight this, 3, 2, -7, 4. So I can actually just substitute these values into my midpoint formula in order to actually figure out what my midpoint should be, right? So that's exactly what I'm going to do, right? So my midpoint formula, once again, is x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? And so I'm going to substitute these values in. I'm going to say that 3 is my x1, 2 is my y1, -7 is my x2 because it's my second x coordinate, 4 is my y2 because it's my second y coordinate. So let's substitute these in, right? So I have 3 plus -7 divided by 2. And then I have 2 plus 4 divided by 2. I'm going to simplify this. So I get 3 plus -7 is the same as 3 minus 7, which is -4 divided by 2. 2 plus 4 is 6 divided by 2. I got even numbers. I'm dividing by 2, so I know I'm going to get a whole number. I'm just going to simplify that a little bit more. So -4 divided by 2 is -2. 6 divided by 2 is 3. So this is going to be my midpoint. Right? Let's move on. Let's try out number 2. If the coordinates of A are -2, 4, and the coordinates of B are 2, -2, what are the coordinates of the midpoint AB? Okay, so let's look at some information that I have, right? I'm given these coordinates, so A is going to be -2, 4, B is 2, -2, and I know that I'm dealing with this segment AB, right? So let's actually draw this out. So I have A here, B here, right? So turns out I actually know the endpoints, right? So I know the endpoints. Right? And then my question tells me to find the midpoint, right? So once again, I can just use that midpoint formula, right? So I'm just going to label this as my -2 is going to be my x1, it's my y1, and then 2 is going to be, there we go. 2 is going to be my x2, -2 is going to be my y2. Just substitute this in, right? Just to refresh, x1 plus x2 over 2, y1 plus y2 over 2. You're taking the average of the coordinates of the endpoints in order to get your midpoint, right? So you have -2 plus 2 all over 2. And we have 4 plus -2 all over 2. I'm going to simplify this. I get -2 plus 2 is 0. 0 divided by 2 is going to be 0, right? And when I actually think about it, what's in between -2 and 2 on a number line is going to be 0, right? So that seems like I did that correctly. Let's look at 4 plus -2, right? 4 plus -2 is the same as 4 minus 2, which is 2. 2 divided by 2 is going to give us 1. So this is going to be my midpoint. Okay? So let's try out number 3. Find to the nearest tenth the distance between 2 points whose coordinates are -2, 5, and 3, -4. All right, so my keyword that I see here that it's telling me to do is to find the distance, right? And distance has a certain formula that's derived from the Pythagorean theorem. We learned about that in 8th grade. But let's just refresh ourselves on what the distance formula is, right? So d, distance, is going to be the difference between our x coordinates. So we have x2 minus x1 squared. If you also wanted to do x1 minus x2 squared, that's going to be fine. You're going to end up getting the same value, right? Because you end up squaring your amount, as long as you're consistent with the next one too, right? So we have y2 minus y1 squared, right? And so when I actually substitute these values in, right, I have that my x1 is -2, this is my y1, my x2, and my y2, right? So I'm going to just substitute those values in. So I have, let's see, 3 minus -2 squared plus -4 minus 5 squared, right? And the whole reason why we square is because we need to think back to our rules in Algebra 1, where, we're not going to deal with imaginary numbers quite yet, right? We're still just dealing in the real number system. When we're dealing in the real number system, we cannot have complex solutions by having a negative number under our square root or a radical sign, right? So we're just going to square this so that we always ensure that we're going to have a positive value, okay? So we have 3 minus -2. That's actually the same as 3 plus 2. So this is 5 squared plus -4 minus 5 is -9 squared. I'm going to simplify this a little bit more. 5 squared is 25. 9 squared is 81, right? So 25 plus 81, mental math, we have 106, right? When I actually put the square root of 106 into my calculator, let's see, we get 10.295, okay, around 10.295, right? But once again, we want to make sure that we're reading our directions pretty carefully. So this says to the nearest tenth, right? So that means I'm going to round to the first place after my decimal point. So that's going to round to 10.3. And that's going to be the distance, approximately, between those two coordinates. All right, let's go to the next one, number 4. In circle O, a diameter has endpoints -5, 4, and 3, -6. What is the length of the diameter? Okay, so it gives me some information, right? Let me just point out this information that I have a circle, I have a diameter, right? So first things first, I'm going to just draw this so I have something to reference. So I have a circle. Okay, that's not that bad, right? This is my circle O, and my diameter is my line that cuts straight through the center from one end to another end, right? And so my endpoints for this diameter are -5, 4, and then 3, -6. And it's asking me to find the length of my diameter. Length is another key word for distance, right? So because we know length is the same thing as distance, we're actually just going to find the distance between these 2 points. So once again, I'm going to utilize my distance formula, right? x2 minus x1, finding the distance between the x coordinates, squaring that. Find the distance between the y coordinates, squaring that, right, in order to find our full distance. So when we do that, we have, I'm just going to label these as x1, y1, x2, y2, just so I can keep all my ducks in a row, right? So when I actually substitute my values in, I have 3 minus -5 squared plus -6 minus 4 squared. Okay, so this is going to give me 3 minus -5 is the same as 3 plus 5, so this is 8 squared. Plus -6 minus 4 is -10 squared. This is going to be 8 squared is 64, plus -10 squared is 100, so this is going to be square root of 164. Okay, and then the square root of 164 is going to be 164 square root around 12.8, right, 12.8, and that's going to be my distance. Okay, start with the next one. All right, next question. So it says the statement x is divisible by 5 or x is divisible by 4 is false when x equals. All right, so I know a lot of you are probably looking at this and being like, what the heck? When did I ever learn this? Okay, so this is from Unit 2, which is our logic unit, right? And I know that this is from Unit 2 because I'm looking at I'm looking at truth values, right? So I'm looking at whether something's false or true and have this logical connector or, right? So when I think back to Unit 2, I learned that when I have this logical connector or, this really means that one or both statements have to be true. That looks like strike one for me, right? So if one or both of our statements are true, then the whole thing is going to be true. And so the only time when your statement that's connected by or is going to be false is when both of the statements are false. So that's really telling me that x has to be some number that's not divisible by 5, and x has to be some number not divisible by 4. So I'm going to look through my answer choices and see whether x is going to be divisible by 5 or x is going to be divisible by 4. If it's divisible by either of those numbers, it's not going to be my answer choice, right? So let's look at the first one. I have the number 10. When I think about 10, is 10 divisible by 5? Yeah, 5 goes into 10 2 times, so I know that 10 is not my answer choice. Number 2. Is 16 divisible by 5? No, it's not divisible by 5. But when I think about whether or not 16 is divisible by 4, I know that 4 goes into 16 4 times, so I know that 16 is not my answer choice either. Number 3, 20. Is 20 divisible by 5? Yeah, it goes in 4 times. And turns out 20 is also divisible by 4. It goes in 5 times, so 20 is not going to be my answer either. So I'm only left with 27. I know that that's going to be my answer choice, but let me just go through it. Is 27 divisible by 5? No. There's no integer where 5 can be multiplied by to get 27. Same thing with 4. There's no integer that 4 can be multiplied to get 27 as well. So that means that 27 is going to be my answer, which is answer choice 4. Some more logic, right? Number 6. Which statement is logically equivalent to if it is Saturday, then I am not in school, right? So when I see this term, logically equivalent, right, I want to think about the contrapositive. So this is a variation of my if statement, my conditional statement. And I know that when I have the contrapositive, which means reverse and negate my statements, right, then I'm going to end up having a logically equivalent statement. So my first statement, right, my first phrase is, let me highlight this in a different color, if it is Saturday, right? So I know that I need to negate this to give me if it is not Saturday. And then my second statement, then I am not in school, right? So I need to negate this. So I'm just going to get rid of the not in it to negate it. So then I am in school. And I'm going to reverse these two statements. So instead of saying if it is not Saturday first, I'm going to say if I am in school, then it is not Saturday. So the only answer choice that matches that is if I am in school, then it is not Saturday, is answer choice 3, right? Next one, keyword, right? We have which statement is logically equivalent to if Andrea gets a job, she buys a new car. So my keyword, once again, is going to be logically equivalent, which should signal to us that we're thinking about the contrapositive, right? Whenever you see the word logically equivalent, you want to think contrapositive. So when we think about the contrapositive, right, we want to think about our conditional statement. If Andrea gets a job, she buys a new car, right? So my first statement that I'm going to be looking at that I need to negate is if Andrea gets a job. To negate it, I'm going to either add the word not or take away the word not if it's already there. I don't have the word not here, so I'm going to add the word not, right? So if Andrea does not get a job, right, does not, to make it more grammatically correct. If Andrea does not get a job, then she buys a new car. Oh, whoops. She buys a new car, right? I'm going to negate that as well by adding a not in there. She does not buy a new car, right? And then Gotta switch these around. So instead of saying if Andrea does not get a job first, I'm going to say if she does not buy a new car, if Andrea does not buy a new car, then Andrea does not get a job. And that's going to be option 2. Let's move on to number 8. So we're moving away from logic now, and we're going to enter into the territory of Unit 4, right? Unit 4 deals with triangles and angle measures, and the number 1 theorem in Unit 4 has to be our triangle sum theorem, which tells us that the interior angles of a triangle, so all the angles inside of a triangle, we know are going to add up to 180 degrees, right? So sum to 180 degrees, right? That's our triangle sum theorem. So let's look at this problem and see what they're asking us, but I think just based on that information, we should know what to do, right? If the measures of the angles of a triangle are represented by x, 3x plus 6, and 2x minus 6, as shown in the accompanying diagram, find the value of x, right? Once again, we know this triangle sum theorem. We know that we can add all 3 of these angle measures together, so let's go ahead and write that expression. So we have x plus 3x plus 6 plus 2x minus 6. And using our triangle sum theorem, we know that this adds up to 180. So all we have to do now is do some simple algebra, right? So we're going to first combine our like terms. I have x, 3x, and 2x, so I'm going to combine them to get 6x. My next like terms are going to be, let me do this in a different color, 6 and minus 6. 6 minus 6 is 0, so I'm not actually going to bother writing anything. And I didn't do anything to the equals 180, so I'm just going to bring it down. Now I need to divide by 6 on both sides to isolate my x, so I get x equals 180 divided by 6, which is 30. So x is going to equal 30, which is answer choice 4. Okay, that was the first page, right? So if you're good with this, right, and you feel pretty confident moving forward, right, you can just stop this here, go on to the next day's assignments. But if you're still struggling with this, I really encourage you to keep watching the rest of the video so that you can actually work through the rest of the problems, understand what you might not be fully understanding, so that you know what questions to ask when we have our phone conference time. Okay, so we did some reviews on Units 2 and Units 4. So we're going to continue reviewing Units 1, Units 3, and a little bit more of 2 and 4, right? So let's look at question number 9, right? Question number 9 says, plane A is parallel to plane B. Plane C intersects plane A in line M and intersects plane B in line N. Lines M and N are blank, right? There's a lot of different planes and lines and intersections going on, so best things to do is to just diagram it out so we have some kind of visual to base this off of, right? So I'm going to say that plane A is going to be this red color, right? So plane A, I'm just going to draw a plane that looks like this, and I'm going to do my best to draw that script A, okay? And then we know that it's going to be parallel to plane B, so I'm going to draw that in blue, whoops, right? Plane B looks like this, another plane, and I know that these planes are never going to touch, okay? And then I have that plane C intersects plane A in line M, so I'm going to draw a plane that intersects plane A, but I also know that plane C also intersects plane B, right? So I'm going to draw this plane intersecting both of these planes. So let's see. Okay, this is my best attempt at plane C. And it intersects plane A in line M, right? So I need to draw a line M. Let's see, line M is going to be yellow. So this is where it's intersecting, right here. This is line M. And then it's going to intersect plane B at line N, right? So line N is going to be some other color. Let's see. Let's do like a pink color. Yeah. Let's do a pink color for line N. Okay. Now, when we look at this, right, we know that line M and line N are both on these parallel planes, A and B, right? So we know if they're both on these parallel planes, that these lines would consequently also be parallel, right? So based on this diagram, I think that lines N and M are going to be parallel since they're on parallel planes to each other. Okay, let's look at number 10. This is going to be a Unit 4 question. I'm actually going to start labeling these with what unit we're talking about. So this is Unit 4, right? In the accompanying diagram of triangle ABC, AC is extended to D, and the measure of angle BCD equals 140, and measure of angle ABC equals 85. Luckily, all that's already diagrammed and annotated for us. And we need to find angle, the measure of angle BAC, which is this angle right there, right? So, this looks pretty interesting, right? So I have that this angle right over here is 140 degrees. And I have that this remote interior angle to it, right, to this exterior angle, is 85 degrees, and I need to find this other remote interior angle. Now, I actually do know a relationship between an exterior angle and the remote interior angles. This is the exterior angles of a triangle theorem, right? So we know that the exterior angle is going to be equal to the sum of your remote interior angles. So let's actually write an algebraic equation that will help us solve this, right? So we know that this remote exterior angle 140 degrees is going to be equal to 85 plus that measure that we need to find, the measure of angle BAC. And all I need to do in order to solve for this is actually just subtract 85 on both sides to solve for the measure of angle BAC. So we're going to do 140 minus 85 to end up getting 55 degrees, right? So 55 equals the measure of angle BAC. I'm going to box my work so I know exactly what to grade. Okay? Let's look at number 11. Same kind of thing, Unit 4. And the reason why, before I even read the question, I knew that this was going to be Unit 4 is I'm dealing with a triangle, and looky here, I have a remote exterior angle, right? So I'm just going to read through the question just to see what they're asking for, whether they want an angle measure or whether they just want the value of x. But just based on the diagram, I know that I should generally be solving for something using my remote exterior angle theorem, right? So let's look at this. In the accompanying diagram of triangle ABC, side AB is extended to D. If the measure of angle ACB equals x plus 30, the measure of angle CAB equals 2x plus 10, and the measure of angle CBD equals 4x plus 30. What is the value of x, right? So it's just telling us to solve for x, so that's exactly what I'm going to do. And once again, I'm going to use my remote exterior angle theorem. So my remote interior angles are 2x plus 10, x plus 30, and my exterior angle is 4x plus 30. So let me just write that algebraic equation that represents what theorem we're going to be using, right? So I have 2x plus 10 plus x plus 30, and that should equal this expression 4x plus 30, right? So I'm going to just combine some like terms here, right? So I have 2x and x as my like terms on my left-hand side, so I'm going to combine them to get 3x. I have 10 and 30 as my other like terms on my left-hand side, and so I know that that combines to 40. Now, I didn't do anything to my right-hand side because I don't have any like terms on that side, but I'm going to start isolating my variable now, right? So in order to isolate my variable, I'm actually going to subtract 3x on both sides. So I get 40 equals 1x plus 30. And then I'm going to subtract 30 on both sides, right? So I'm going to subtract 30 here to get 10 equals x. Woohoo! We're done with that one. Okay? So use your diagrams, right? Your diagrams should probably tell you before you even start your problem what you're supposed to do. And based on this diagram, because I saw that exterior angle, I knew that I was probably going to have to use my exterior angle theorem. Let's try out this one. If triangle ABC is congruent to triangle DEF, then segment AB in triangle ABC is congruent to what segment in triangle DEF, right? So, just based on this, right, I'm dealing with triangles, so once again, I'm dealing with Unit 4, right? And we learned that the naming of triangles is super, super important. And same with the naming of angles. Whenever we're talking about congruency, we want to make sure that whatever is congruent corresponds in how we're naming it, right? So if I named my triangle ABC, right, then, and it's saying that it's congruent to triangle DEF, then I know that AB, these two connected letters AB, right, should be congruent to these two connected first letters in the next triangle, DE, right? So I know that AB is going to be congruent to DE, right? So the naming of triangles, angles, segments are all very important because it should be as clear as possible what's congruent and what the relationships are between these actual parts of these geometric figures, okay? Okay, so we just did a great job of covering units 1, unit 2, and unit 4, right? But we haven't seen a ton of questions from unit 3. So page 3, starting from question 13, is one question that will kind of get us into reviewing unit 3, right? And the reason why I know that it's reviewing unit 3, which was my unit about lines, is because it literally has the word line in it, right? So I know that word line, and also I'm dealing with perpendicular lines, and so I know that this is going to be a unit 3 kind of question, right? So let me just annotate that, unit 3. Okay, so my question's asking me, what is the slope of a line that is perpendicular to the line whose equation is y equals 4x plus 1? Right, and whenever I see the word perpendicular, I want to think about slope, and I want to think about opposite, sine, and reciprocal, which means a flipped fraction, right? I'm going to rearrange my numerator and denominator to be denominator over numerator, right? So when I look at the original line that I'm given, it's in slope-intercept form. And I know that it's in slope-intercept form because it follows the form y equals mx plus b, where m is going to be my slope, right? Slope, right? So I want to find what's my coefficient for x so that I know what my slope is. Turns out my slope is going to be 4 because that's my coefficient for x. So if my original slope was 4, m equals 4, my slope of my perpendicular, which I annotate as this, right, is going to be the opposite sign, negative 4, and the reciprocal of that, 1 over negative 4, which is option 1. Now you might be asking, how do I know that the reciprocal of 4 was going to be 1 over 4, right? And so the reason why I know that is because 4 can always be rewritten as 4 over 1. And I just have to flip those in order to get my reciprocal. Okay? Let's try out number 14. It asks me, which is an equation of a line parallel to the line whose equation is 3y equals 2x plus 3? Once again, this is a unit 3 question, right? Unit 3, because I'm dealing with lines and I'm dealing with parallel lines specifically. Now I'm given this equation, right? 3y equals 2x plus 3. So before I even go into thinking about parallel slopes and stuff like that, I want to first convert this into slope-intercept form because that's going to be my easiest way to identify slope. So I have 3y equals 2x plus 3. To get it into my slope-intercept form, I need to solve for y. I need to get y by itself. And right now I have this 3 as a coefficient for it. So to get rid of multiplying y by 3, I'm going to divide both sides of my equation by 3. And so this is going to look like y equals 2x over 3 plus 3 over 3. 3 divided by 3 is 1, right? So this is my equation in slope-intercept form, right? I love slope-intercept form because it easily lets me see what my slope is. I also really like point-slope form because it also lets me very easily see what my slope is. Whenever we're given something in standard form or neither of those forms, right, we want to make sure that we're converting to either point-slope or slope-intercept so that we can gain a little bit more information about what our line's telling us. Now, when I see this word parallel, right, I once again want to think about my slopes, and parallel lines have equal slopes, right? So if my slope over here is 2 over 3, right, because that's my coefficient for x, I need to find another equation over here that also has a slope of 2 over 3, right? And I can see right over here with option 2, right, that my slope is 2 over 3 because that's my coefficient, right? In addition, I want to make sure that my y-intercept is different because if it's the same y-intercept, same slope, They're actually just the same line, and parallel lines should never touch. Same lines touch all the time, right? Because they're right on top of each other. And when I look at my y-intercept, which is this b term, 3 over here, I see that it's different from my y-intercept in my original line, which is 1, right? So because it's a different slope, different y-intercept, same slope, I know that 2 is going to be my parallel line. Okay, so I think we're pretty good with number 14. Let's try out number 15. What's the keyword that we see, right? We see the word line again. Once again, this is going to be a Unit 3 kind of question. So, because we're dealing with Unit 3, that's actually right, Unit 3. Let's annotate that. So that when we're going back and reviewing this, and we're like, which questions was I really struggling with? If I see that I constantly was struggling with Unit 3 questions, I know to review Unit 3. Okay, let's look at this question. What is an equation of the line that passes through the point 7, 3? Okay, so I'm given a point 7, 3. Let me just annotate that. 7, 3. And it's parallel. Oh, okay, I see this keyword, parallel, to the line 4x plus 2y equals 10. This line is in standard form, so I know that I'm going to have to do some kind of transformation to it algebraically so I can convert it to slope-intercept form. Okay. So the first thing that I'm going to do is actually just convert that line that I was talking about, right? So I have 4x plus 2y equals 10. I'm going to just write it in slope-intercept form because I think that that's easiest for me, right? So I'm going to first subtract 4x on both sides because remember, whenever we're trying to convert to slope-intercept form, we're just solving for y. So when I do that, I get 2y equals 10 minus 4x. Remember, I'm not combining those terms because they're not like terms. Now, finally, I want to divide by 2 to my entire expression on the right-hand side. So I got y equals 10 divided by 2 is 5. Negative 4x divided by 2 is negative 2x. Okay, so when I look at this, right, I think that my slope is going to be whatever coefficient I have next to my x. And my coefficient is negative 2. Carry that sign over. Don't forget that sign, right? So my slope is going to be m equals negative 2. And I know that I have to have a parallel slope to this, right? So my slope parallel is going to be equal to whatever the slope was from my original line, which is negative 2. Okay. Now, I'm given a point. So if I'm given a point, right, and I'm given a slope, I can write point slope form, right? So my point slope form is going to be y minus whatever the y coordinate is, which is 3 over here. 3 equals m, my slope, which is negative 2. Negative 2 times x minus my x coordinate, 7. Now, looks like I have a bit of a problem. Okay, it's not a huge problem, right? When I look at my answer choices, they're all in slope-intercept form. And I know this because my y is isolated for all these equations. So what I want to do with my point-slope form is actually just solve for y, right? So I'm going to add 3 on both sides. So I get y equals negative 2, x minus 7, plus 3, okay? And I want to distribute the negative 2, right? So I get negative 2x plus 14 plus 3. And then finally, let's see if I have enough room over here. I have negative 2x and 14 plus 3 are my like terms, so I have plus 17, right? And so this is actually going to be my equation for y. So this equals y. So when I look at my answer choices, the only one that matches that is going to be answer choice number 4. So 4 is going to be my answer. That one was a little bit more involved because it required us to convert to several different forms of an equation for a line, right? So if that one was pretty tricky because it's a multi-step kind of problem, let's try out number 16 because it's going to be pretty similar. So for number 16, once again, I know that this is a Unit 3 question. Right, for Unit 3 questions, I know that I'm dealing with lines and equations for lines. So let's see. What is an equation for a line that is perpendicular? Okay, keyword, I'm going to annotate that. Perpendicular to the line, so this is my given line. So I'm going to annotate this, and my equation is y equals 3 over 5x minus 2. Bless up, that's already in slope-intercept form. Don't need to do anything further to that. And it passes through this point, right? 3 comma negative 6. It passes through this point, right? So with my given equation, right, y equals 3 over 5 x minus 2, right? I'm pretty happy about the way that this is given to me because I can clearly identify that my slope is 3 over 5. So my slope is 3 over 5. I'm asked to find the perpendicular slope, right? So whenever I have to find my perpendicular slope, I know that it's going to be the opposite sign and the reciprocal of this, right? So it's going to be negative because this original slope was positive. I'm going to flip my fraction, right? So this is a slope that I'm dealing with when I'm making my equation. Now, I'm given a point. So whenever I'm given a slope and a point, I can write this in point slope form, right? So my point slope form is going to be y minus my y coordinate, negative 6, equals negative 5 over 3, parentheses, x minus my x coordinate, 3. Okay. Once again, same kind of problem as before, right? Where all of my answer choices are given to me in slope-intercept form, right? So that means I'm going to have to do some manipulation. Let's work out that manipulation, okay? I'm going to convert this into slope-intercept form by solving for y. So the first thing that I'm going to do is actually just simplify whatever I can, right? So I have that this is y minus negative 6. That's the same as y plus 6, and that equals negative 5 over 3, x minus 3. Okay, looks like I can subtract 6 on both sides, right? So then I have y equals negative 5 over 3, x minus 3 minus 6. Okay, why don't I distribute so I can combine like terms in just a bit, right? So I'm going to distribute this negative 5 over 3. So I get y equals negative 5 over 3x plus 5, because negative 5 over 3 times negative 3 is positive 5. And then I didn't do anything to my minus 6, so I'm going to bring it down. All right, I'm going to combine these two like terms over here. Positive 5 minus 6 is negative 1, so this is minus 5 over 3x minus 1. And this is actually going to be my equation. Right, so let's see which of my answer choices matches that. Looks like answer choice number 3 matches that, so let me just circle that. Okay, if you're struggling with these problems, right, you might want to look back in your Unit 3 review problems at the end of the packet, because there are a lot of problems like that that can help you work through this multi-step process. All right, now, I see some lines again, right? I might be dealing with angles during this because I have parallel lines being cut by a transversal, and I know some of those relationships, but because I'm once again dealing with lines, I'm still working in Unit 3. Right, and so given this diagram, right, CAB is parallel to DOG, and AO is a transversal, right? So I'm going to actually just annotate this. So CAB is parallel to DOG, and AO is my transversal T. Right, and I'm given that CAO, this angle, and DOA is this angle, right? And I want to find the measure of angle COA, which is this angle over here that's given by 2x. Okay, so you might be like, oh, what am I going to do with all this information, right? If I have parallel lines, I know that there are special relationships that happen with certain angles, right? So when I look at both of these angles, they're on the inside of my parallel lines, right? Because they're in this space over here, right? And they're on the same side of my transversal. So let me actually, instead of doing that in full color, let me just actually highlight that, right? And they're on the same side of my transversal, right? They're both on the left-hand side of the transversal. So they're on same side of T, right? So they're on the same side and the inside of your parallel line. So this is going to be same side interior, right? And when you have parallel lines and same side interior angles, they have a special relationship. They're going to be supplementary, meaning that they should add to 180 degrees, right? So let's actually set up an algebraic equation that we can use to solve for x so that we can find the measure of angle CAO, right? So I know that this angle CAO, which is represented by 2x, when I add it to angle DOA, which is 3x plus 40, they're supplementary, so they add up to 180. And I'm going to work some algebraic magic in order to solve for this, right? So 2x and 3x are my like terms, so this is going to be 5x. We didn't do anything to 40, so bring it down, equals 180. I'm going to subtract 40 on both sides to get 5x equals 140. And so x is going to equal, what is that, 28? Is that right? Yep, that looks right to me, right? So x does equal 28. Whoops. So we just solve for x. Doesn't seem like we're actually done though, right? Because when we look back at the problem, it's saying to find the measure of angle CAO, right? And I know that CAO is represented by this angle here that has a measure of 2x. So what I want to do is actually just substitute this into what I know, right? So CAO equals 2x. I know what x equals now. I just solved for it, so I'm going to just substitute it in. 2 times 28, that gives me 56, right? So the measure of angle CAO is 56 degrees. I'm just going to circle my answer, right? Unit 18, question 18. We have not gone to Unit 18. So question 18 is once again another Unit 3 question. So let me just annotate that, right? Line N intersects lines L and M, forming the angles shown in the diagram below, right? So over here, right, these two angles, they're both on the inside of these lines, right? So let me just say that they're on the inside, right? And then they're on opposite sides of this transversal N, right? So because they're on the inside and on alternate or opposite sides, right, I know that I'm going to have alternate interior angles. Now, if L and M were parallel to each other, like over here, right, we know that alternate interior angles would then be congruent if we have parallel lines, right? So let's figure out what x would be so that these two angle measures would be congruent, so that L and M can actually be parallel, right? So what I'm going to do is actually just set up an equation where I set these two angles equal to each other. So I have 6x plus 42 is equal to 18x minus 12, right? Go ahead, let's solve for x, right? Because it's asking us what the value of x would be, right? What the value of x would be. Sorry if you're getting whiplash because I don't really know how to use this program very well. Okay, so I'm going to subtract 6x on both sides to get 42 equals 12x minus 12. Okay, I'm going to add 12 on both sides to get 54 equals 12x. All right, and then I want to divide by 12 on both sides. And when I do that, I have 54 divided by 12, which is 4.5. 4.5. Okay, so x equals 4.5. Let's see, that looks like answer choice 2. Looks like we're solid. Okay. If you were struggling with this, looks like you got to review Unit 3, right? If you have any questions on these, let me know. This is a great way to specify what kind of questions you have. All right, last page, right? Last few problems. We're in the home stretch, right? So let's look at question number 19. It says G is the midpoint of FH. FG equals 8x plus 15, and FH equals 11x plus 75. We want to find x, and we want to find GH. Okay, so I know that I'm dealing with a line segment, right? So you might think, oh, this is going to be Unit 3 work, right? So this goes into Unit 3. We did cover a little bit of this in Unit 3, but that was actually a review of Unit 1, right? So this is Unit 1 and Unit 3, okay? So I'm given that G is the midpoint of FH. So before I even do anything, I just want to draw a diagram so I have some kind of like frame of reference to refer to. Oh gosh, that's not straight. Okay, this is my segment, FH, right? G is the midpoint, so I know G is in the middle, so I'm going to write G over there. And it tells me that FG equals 8x plus 15. 8x plus 15, let me annotate that. And FH, this whole thing, is 11x plus 75. Now, I know because G is the midpoint, FG and GH are actually congruent. So if I know the measure of FG, I know GH is actually going to be the same measure, so that's also going to be 8x plus 15. right? So to deal with part A, right, I'm going to need to set up some kind of algebraic equation, right? So I have 8x plus 15. And instead of writing plus 8x plus 15, I'm just going to write times 2 because that's equivalent. And I know that's going to equal this entire thing, 11x plus 75, because of my segment addition postulate, right? Let me just annotate that. Kind of small. So this is going to be my segment addition postulate. Okay. So what I want to do now, just go ahead, let's work our algebraic magic, right? So I want to distribute this 2 to everything in my parentheses to get 16x plus 30 equals 11x plus 75, right? I'm going to subtract 11x on both sides and also 30 on both sides to get 5x equals 45. I'm going to divide by x on by 5 on both sides. Oh, don't divide by a variable. So I get x equals 9. Okay, so that's part A, right? Part A was to find x. I'm going to label that as part A. Okay, x equals 9. Let's work on part B now, right? Part B is saying to find GH. Well, I know that this expression, let me just highlight it, this expression 8x plus 15 represents GH because I deduced that from some of my given information. So I have 8x plus 15 equals GH, right? Looks like I know what x is now, so I can actually substitute that in. So 8 times 9 plus 15 equals GH, right? And then I'm given that this is going to be 72 plus 15 equals GH, right? I'm going to add these together. So this gives me 87 equals GH. And this is part B, so let me label that. I'm going to box my answer so I know what to grade. Okay? So Unit 1 and Unit 3, right? This is really going into, do you know how to diagram, right? Do you know how to annotate so that you can actually solve your problem? And so if you're still having trouble with this, I really recommend that you go back to Unit 1 rather than Unit 3. I know that this is still dealing with the lines, but this is more of a Unit 1 problem than a Unit 3 problem. Okay? Unit 2, question 20, there we go. In triangle ABC, the measure of the second angle is 3 times the measure of the first. The measure of the third angle is 25 less than the measure of the first. Okay, so automatically, right, I know that I'm dealing with Unit 4, right? This triangle ABC. Whenever I'm dealing with triangles, I'm dealing with Unit 4, so let me just annotate that. This is Unit 4. Okay. Now, the measure of the second angle is 3 times the measure of the first angle. All right, I have no idea what they mean by second angle, first angle, whatever, so let me just draw a diagram so I can just find my bearings, right? So I'm going to draw a triangle. I'm going to draw a triangle A, B, C. I'm going to just say that angle A is my first angle, angle B is my second angle, and angle C is my third angle. Okay? So it's saying that the measure of the second angle, so I'm going to say that the measure of the second angle, right? So this is talking about angle B, is 3 times the measure of the first angle. So this is talking about measure A, right? And the third angle is 25 less. So the third angle, C, is 25 less than the measure of the first angle, A. All right, so why don't I actually try writing some expressions for this information that I was given, right? So I know that B is equal to, because I have that keyword is, 3 times, right? So 3 times the measure of angle A. So 3 times A is just 3A. Okay. When I look at my next one, my third angle, C, okay, so C is, so equal to, 25 less than, okay, so this is going to be A minus, A subtracting 25. The less than key phrase really gets people. Whatever value you have before less than goes after your subtraction sign, okay? So, we don't have any information about the measure of angle A, but we know that A is just equal to A, right? That's the reflexive property, okay? So it's asking us to find the measure of all angles. Okay, so if it's asking us to find the measure of all angles, I know that all three of these angles, because they're the interior angles of a triangle, should add up to 180, right? Based on my triangle sum theorem. So I'm actually just going to create an equation where I'm going to add all three expressions. So I have 3a plus a minus 25 plus a equals 180. Okay, now I'm going to combine my like terms. So I have 3a plus a, that gives me 5a minus 25 equals 180. Going to add 25 on both sides. So I get 5a equals 205. And so a should equal 41, right? So a equals 41 degrees, right? Now, using that value for a, I can actually just substitute these in order to find b and c, right? So if a is 45 degrees, right, I know that b equals 3 times a. So this is going to be 3 times 41 after I substitute that value in, and that gives me 123. So that's going to be my b. Okay, and then c is a minus 25. I'm going to substitute that value in 41 for a. Okay, and then 41 minus 25 is 16. So I'm going to write 16 for c. Okay, looks like I solved it. So those three angle measures, that is going to be part A. So let me just write that over here just so that I don't forget, right? So I found that A equals 41 degrees, B equals 123 degrees, and then C equals 16 degrees. Okay, so I solved part A. Now I need to find part B, right? And part B says the measure of the exterior angle located at the first angle. And I already said that the first angle, I hate this first angle, second angle, whatever thing, that's just angle A, right? So I need to find the exterior angle located at this angle A, right? So I'm just going to draw an exterior angle outside of here, right? I know that this exterior angle is going to be the sum of angle B and angle C, right? So I just need to add, right? So the exterior angle of A, so exterior of A is going to be the sum of the measure of angle B plus the measure of angle C, because those are the remote interior angles to that exterior angle, right? And so the measure of angle B, I already said, was 123. The measure of angle C was 16. So when I add those together, that should be 139 degrees, and that's going to be my exterior angle, right? So let me just write that next to part B, so I know exactly what I'm talking about. So it's going to be 139 degrees. There we go. Okay. Last problem. All right. I see this keyword triangle in it, so I already know this is also going to be Unit 4 question. So Unit 4. Okay. In a triangle, the measure of the second angle, oh my gosh, second angle, first angle, third angle. I hate this. I hate this nonsense. I'm going to draw a triangle so I can get my bearings straight and I can actually label these triangle angles. So I have this triangle, right? And I'm just going to call it ABC again because I like those letters. All right, I'm going to say that angle A is going to be my first angle, second angle, third angle. Okay? So in a triangle, the measure of the second angle, scratch that, I'm going to say this is angle B, is 6 more than twice the measure of the first angle, scratch that, going to call that angle A. Okay? And then the measure of the third angle, scratch that, this is angle C, is 18 less than 3 times the measure of the first angle, scratch that, call that angle A. Okay? So then I want to classify the triangle as acute, obtuse, or right. And I can't really do that until I know what those angle measures are. So let me actually create those algebraic expressions so I can solve for each of my angle measures, okay? So my first one, I'm I'm going to use the first piece of information. So I know that I'm going to create an equation for b. So b is equal to 6 more than, so 6 plus twice the measure of the first angle. So twice, 2 times the measure of a, right? So that's my equation for b. I know that I have an equation for c, right? Because it says the measure of the third angle c is 18 less than. Okay, so remember that less than, the 18 follows the subtraction sign, okay? 3 times the measure of a, right? So 3 times a, okay? And then a is just a. I'm going to use my triangle sum theorem again, right? So I know that 6 plus 2a, 6 plus 2a plus 3a minus 18 plus a, that all equals 180. When I add my like terms together, I get 6a minus 12 equals 180. 6a equals 192, and then a equals, I can't do this off the top of my head, 192 divided by 6 gives me 32. So a is 32 degrees. Okay. Now I can actually substitute these values in, right? So I can find out what c equals, right? So c equals 3 times 32 minus 18. 3 times 32 is 96, minus 18 is 78. So this is 78 degrees. Okay. And then finally, we have 6 plus 2, going to substitute 32 in for a. Oops. 32. Okay. And then I have 2 times 32 is 64 plus 6, which is 70. Okay. So when I look at all 3 of these angle measures, they're all less than 90 degrees. Because all of my angle measures are less than 90 degrees, I know that this is going to be an acute triangle. All right. Congratulations for making through this entire review. If you were having any questions on a particular question, or we're getting a lot of questions from a particular unit wrong, these are the types of questions that you should be asking me when we have our phone call. All right. So good luck with the rest of your work, and make sure that you ask me any questions if you have any. Thanks. Bye.